So, in about a week or so, I have an extremely important economics exam, but instead I decided to think about the 4-4s challenge. Now, if you like math, or if you see math, you might have seen this, and if you haven't, well, now you do. The 4-4s challenge is basically that challenge where you try and rearrange 4-4s in order to write any single number at all. I think the website that did it best was Murderous Maths. This website is old. It's older than me. I think they managed to do it pretty well. They gave answers for all of these numbers from 1 to 100. But then when they went from 101 to 200, they started using the integer function, which is it's kind of cheating. That got me thinking, what if instead of 4-4s, I used 3 3s? How far can you really go with 3 3s? It seems like there's not actually a lot you can do, but let's test it out. I'll set the rules. The 3 key must be input 3 times. Seems simple enough. And if the equation works on a calculator, it must be accepted. I'm using a Casio FX97SGX, but if you want, you can use any calculator ever or something. No other numbers apart from 3 can be input. This is pretty obvious. You can't put in 4 because it's not 3. And a decimal point cannot be used to represent 0.
So this one might need some explanation. Basically, on my calculator, you can use the decimal point and it will give you 0. So this is really annoying because if you know your math, you can easily use this to make any number you want. But I don't want to do that, so I'm excluding that.
Let's move on to rule 5. Sine to the power of -1, cosine to the power of -1, and tangent to the power of -1 are the only exceptions to rule 3. This is because I need them. They are very important. And also because they can be written as arcsine, arccosine, and arctangent, so it's not really cheating. Now, let's move on to chapter 1, the basics. Obviously, the multiples of 3 are pretty easy to do. And if you use divide, you can get 2, 4, and surprisingly 11. However, there's a little bit of trouble when you try and do 1, or 5, or 7. We need to introduce the new symbol, the factorial. And by new symbol, I mean old symbol, because everybody knows what this is, everybody knows what it does, but it does give us a way to make 6 using only 1 3. So with it, we can make 2 as well. This allows us to make 1, 4, 7, and 8 using only 3 3s. However, the real issue comes when we try and make 10. Now, if you've seen this sort of thing before, you might know that Presh Talwalkar already did a video on this. He did a good job, but he only went all the way up to 10. And if you've seen this video, you might think that you know the answer. Oh, you're wrong. You silly goose. You blockhead, you clown, you walnut, you horseshoe magnet, you macro, you 3D computer animated, this is it. This is how you make 10 using only 2 3s, by using 0.3 to represent 3/10. Presh Talwalkar didn't cover this in his video, but it was in the comments, so good for the comments for being awesome. Of course, this isn't 3 3s, and I want 3 3s, so I'm going to use a square root here and multiply 2 3s together. This is probably the only time we'll cancel out 3s in this way. Using this strategy, we can make 13, 14, 15, 16, 17, 18, 19, and 20. 19 especially takes a little bit of finagling, but if we swap around a couple of signs, we can turn 19 easily into 21. Similarly, we can turn the formula for 17 into 23, the formula for 4 into 24, because 4 factorial is 24, and the formula for 14 into 26. However, try as we might, we cannot make 22 or 25 using only 3 threes, not even when we try and use 3 cubed to make 27. Now let's go back to rule number 5. Sine to the power of -1, cosine to the power of -1, and tangent to the power of -1 are the only exceptions to rule 3. Now here's a table. You see where I'm going with this? You see it? There's a way to make 60 using only 1 3. Of course, there's also a way to make 60 using 3 threes, but using this, we can make 48, 50, 51, 57, 58, and 59. We can also make numbers above 60, though I don't really want to cover that. We can make 61, 62, 63, 69, nice, 70, and, well, we don't need to use 72. You can see that we actually use 3 with 2 factorials on it, which is actually 6 factorial, which is 720, and by dividing that by 10, we get 72. 720 is also useful because it's 360 multiplied by 2, which means that cosine 720 is 1. This means that we have a way to make the number 1 using only 1 3. If we take the arcsine of this, we get 90, which we can use to make 29 and 31. 30 is also pretty simple. And if we take the arctangent of this, we can get 45. This means that we finally have a solution for making 25. In fact, we have solutions for all of these numbers: 28, 32, 33, 34, 36, 39, 40, and 42 being way simpler than 35, 38, 41, 43, 44, 45, 46, 47, and 49. However, we still can't make 37, or 22. Now let's look back at this table. Since we can make 60, 90, and 45, we should also be able to make 30. This is an extremely common formula in algebra, because if you've been a math student like at all ever, you would have seen it. So by shuffling some of the parts around, we can easily turn 60 into 30. This seems to be the simplest way to turn 3 into 30. I could not find a simpler way. But with it, we can easily make 37, although this is pretty long. However, we still have to make 22. How do we make 22? Alright, let's review what we've learned so far. There are many ways to express 3 as a variety of different values. You can express it as 3, 0.3, 6, or 720. Which we can then use to make 2 using 2 threes, 10 using 2 threes, 20 using 2 threes, and 1 using only 1 3. We can also make 27 and 33 with 2 threes. Using more trigonometry, we can make 30, 45, 60, and 90 using only 1 3. This can come in simple terms like when you use it to make 54, or more complicated methods, like when you make 52 or 53. You can also shuffle some of the parts around. If you change a minus to a plus, you can easily make 55. Or if you remove a factorial, you can easily make 56. The number 22 itself has a lot of ways to make it, but if you try and convert it all to threes, you can never seem to make anything using less than 4 threes.
Man, if only there was a way to make 2 using only 1 3. But see this is the closest I could come up with. It needs secant, but my calculator doesn't have secant, so I can only use 1 over cosine, which means I have to use the number 1, which either requires 1 3 or is against the rules, which is annoying. The closest I can do with only 1 3 is 1/2. Wait.
You can make 1/2 using only 1 3. Okay, I think I've got it. Introducing the new and improved formula for making 22. What I did is I took 45, multiplied it by half to get 22.5, then I subtracted half to finally get 22. That was kind of complicated, but I can finally say that the 3 threes challenge is complete from 1 to 63. That's where I'll be stopping today. If you want me to do more, leave a like, and if you want me to do less, leave a like, and if you hate me, please leave a like. Also subscribe. Wait, what?